and gentlemen, the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. On with the show. Ladies and gentlemen, welcome to my channel. My name is Keith and I'm your host. This is 4 Inches Longer, Part 3. Alright, we've turned the outside and then we brought it up to the chuck here so that we were more true. We redialed here. We went ahead and drilled out the pilot, or created a pilot bore, and we've set up our tracer attachment to do the taper bore. We'll bring you in close, show you how I had that set up there, and of course we're just roughing this out right now. Then we're going to be doing some adjusting and detailing on the outside before we go for the final finish on the bore. We also have to make a broach guide, so we're going to be combination with turning a broach guide and doing the finished bore all at the same time, so that we can gauge that bore to be the right size to fit that shaft. All right, and we got the coupling that fit with that shaft we're making this for, and that's going to really detail that taper and the size of that taper. Alright, I have many other videos on my channel that actually show setting up and using the tracer attachment, but I like to go through the basics of it. We have a master taper. This is 3/4 inch per foot mandrel. We've done several things with this, including sliding couplings or whatever, and modifying or machining exterior parts of that, or facing them off, or things like that. But this stylus actually controls this link arm, and this arm comes up here, and there's a spool valve in here, and this actually shifts this back and forth, and that's what controls the in and out of the taper, or trace. I should say trace, because it doesn't matter what the shape is back here, this stylus will come up against it and then follow it. Alright, this right here is a long T-slot, precision mounted to the bed of the ways so that everything stays nice and uniform, and you can slide these carriers. These carriers have adjustment nuts inside and out, so you can adjust in and out, and then these two centers come in, and you can actually move the pattern towards the tailstock end or the headstock end, so it's very versatile. So this kind of gives you an idea. Then this stylus will come in and touch there. I'm going to go ahead and just bring it in so that you can see that the stylus, now if I was to push back on the stylus or create any power, and I've just got my fingernail there, so you can see how easy that actually moves. And then you have a lever here that actually throws it back so it'll retract when you want it to retract. Now when you're doing a bore on the back side here, you leave it in and then you follow the lathe. You leave it engaged all the time when you bring it back. You can't have it come out, because then it's going to put bar pressure against the bore side and you're going to screw up your part. Alright, I'm going to give you this perspective here. Of course, you already saw where the stylus comes in and touches the taper there. Here's my handle that controls the in and out. Okay, I center it up as far as when you bring the table in and out here, until a couple times when you're moving it around and feeding it, and you gotta bring a little bit, you gotta exercise the hydraulics a little bit. Alright, and then it stops chattering. Alright, so we go ahead and we bring it in, and then we come in next to our edge right here. We know that we have already adjusted so that we know that we're going to be able to follow that taper mandrel for the length of our bore inside here. We're only going 5 1/4 inches, and we have probably 8-9 inches of travel on that mandrel back there, and we have enough depth here, which I was saying that the center of travel and adjusting of the table or the cross feed kind of helps you do that, so that your position of tracing, whether you go in or out, is still the same in relationship to the stylus, but the hydraulics shift the spool valve so your ram can be centered, but your top tip stays where it's supposed to be. Alright, now we're going to come in, and this adjustment here adjusts the amount of material that we're going to be taking per pass. So I bring it out here till I actually just start touching. I don't know how. This is just a regular brazed bar tip, brazed bit in this bar. And this bar clamps, I made these up quite a while ago, and I made this so that you could change out the bar to the holder, so it's like a set. But this is one of our larger bars, and gives us the stoutest cut in here. I'm going to go ahead and feed it in. So we're going to take a 16th per diameter, and be like 32 thousandths per side. And I'm going to go ahead, lighten up the feed just a little bit, because this is not a coarse action here with this setup. And as that comes in, it's following that taper mandrel, which gets smaller towards the headstock, creates the bore going in this way here. The shaft will be going into the coupling from this side. Okay, this is our second cut in, and we're going to come back and we're going to try taking just a little bit more. Okay, there's 10, 20. We're going to skip the 5. So we got that's taking about 25 per side. We're doing pretty good. That sounds good. We just put in 50 thousandths, and we're doing 50 thousandths per side, so that's 100 thousandths out of the bore. So she is cutting pretty well. Okay, bit still looks pretty good, and we're at about 2/300. And of course, we know that this diameter here is going to be pretty close to 2 3/4. That's the shaft size. All right, we're going to go ahead and put another 50 thousandths into it. 10, 20, 30, 40, and there's the 50. That's per side. Even sometimes when there's plenty of material there, you don't need to overdo. You don't need to overdo it. Once I asked my mentor, I said, I just slammed out job after job after job all day long. And I said, hey, you got something I can up in 20 minutes? And he gave me a propeller to bore. And less than 20 minutes, I picked that up. So. Excuse the French. We finished up our broach guide. This is our broach here, and the guide lets us do single push strokes, lay in a shim, do another stroke until it progresses outward and creates the keyway depth. Now this has already got a keyway in here. This coupling is the original coupling off the shaft. Now I made the slug and fit it, the taper and everything else, to match the taper in here, and we fit that in there, and we set that up in our in our keyway cutting jig that we cut keyways in the shaft. So I was able to hold that and put the angle of the broach parallel with this surface here. Oh, and then I just cut it off to the usable length, which is about 1/4 inch up here, and I have it sticking out down here about 5/16 of an inch. Now we need to go ahead and finish this bore on the new coupling. But before we work on this finishing the bore, we need to skim cut the entire outside so that all surfaces are running perfectly true with this face and this register, so that when it's put and mounted onto the shaft, those two surfaces remain running perfectly true with the shaft. Now, we do have, okay, that fits so good I gotta lightly tap it out. There we go. Oh, one thing before, which is, while we have that in here, just so you can see, with the finished bore at the size it needs to be, that blue line is where it sets against the back of the face, which is the back of this face. So we're gonna slide this down in here. Okay, so the total amount of distance that we need to get this to travel in there more is just under 1 3/4, 1/700. And basically it's a 32nd or 3/4 inch per foot. Comes out to figure out about, I don't know, about 8 thousandths every 1/8 of an inch, something like that. So we've got probably about 60 to 80 to come down into this area where we're going to want to really be critical of our taper contact and the position we want it to lap fit it onto the shaft. All right. So that's about where we're at. We're going to go set up 2 centers. We're going to turn this between 2 centers so that we can into it, and skim all surfaces on the outside. So let's head on over to the lathe and do that. Okay, we've got our center set up here, and I actually made 2 cuts. I got 2 tapers there. It's a step plug here, and it has a nice flange so you can push hard against the jaws, and that's all set. It's been locked down, pushed on it, and all of that. So we put our bell center in this side here. Alright, and give it a little tension here. That's going to be real light cuts because I don't think we're going to need a dog to drive this, and we're only talking about skimming this, so we're not going to be taking off any major cuts at all because we only have 10, 20, 30 on various diameters and faces, and that radius right in here. Alright, my eyeball, she looks like she's running pretty darn good, so we were able to keep it most of the time. I can see a little variable right here in this cut here. So this outside diameter and that at the time that this cut was cut, there might be a little discrepancy in there. This outside or back face here looks like it might have a little bit of run out and maybe a little bit on the front. So set our coffee out of the way here. All right, you just check a couple here. Let's just see what we got on this face here. Okay, 2 thousandths on that face. On this outside here, under 2. We're not straight in on our plunger, but we're okay, about 3.5 there. About 3 there. Oh. I never quite tightened that up. All right. About 1.5 right there. So we're coming down the line, and we're going to be able to make everything 100% running concentric with each other. And then from there, we can forge out, and you can make anything else on this run concentric by dialing in all of our diameters and proving 0, and then whatever we machine from there will be 0. We're going to try something new. I have one of these Rook magnetic mag base. They made to hold indicators, a lot of other things there. Real handy. You could put a 1/4-inch rod with a bolt clamp or whatever, and you could hold your cool mist thing in the mill, whatever you want. I put a 1/4 bolt that I cut the head off on here. That gives me the threads over here, and I sandwiched a position, and I drilled a couple holes in this 1-inch brush here so that I could stick this onto the tool bit, bring the brush over the top of the tool bit, because on ductile material, cast iron, if you're running tool bits upward, the chip's going to fly upwards. That's why you saw me hogging everything with the bit hanging down, because I just needed to get the material off of there, and I needed to go down out of the way and not up in the air as much as possible, even though chucks and jaws act like a fan, so it'll suck and then it distributes from your chuck jaws and everything else like a centrifugal fan. That's what that ends up being, no matter if it's a 3-jaw, 4-jaw, or whatever. All right, so I've got this here, and I can go ahead and bring this down over the top. If I was going to turn, I'd probably want it here. And see, now I'm going to do the face. I might actually want to come over here on this position here, so that this can travel in with the face, making sure your clearance is and your travel and all of that's going to come into play. All right, and what's nice is you can flip it out of the way. Once you touch off and you know where you're at, you can bring this down in and you can keep it up there. So let's give it a shot. We're just going to take a light skim and get rid of that 2000s that we had up there on that. All right, we're going to come in. I'm going to lightly touch that face, and we can see it's skipping there. And I'm going to put in about 3 thousandths in here. Okay, now we can just put the brush down like this, and we're going to see if it's going to help us out a little bit more. Now, chips are hot, and they will burn the bristles on the brush. And your brush is going to wear out after a while. But it does keep them down there, and nothing's flying up in the air here. Okay, that was cool. So on that side there, well, being magnetic, magnets always have the drawback a little bit when you're using ductile iron, but or cast materials, or even steel. But these chips are light, and they do stick to magnets really well. Okay, so we go ahead and reverse it, so we're over on the other side, and we'll be able to lower that down just like that right there. Okay, and we can feel that surface is not, you know what, probably, oh yeah, there's a better surface right up on the side of there. This has a label on it that's kind of hindering it. Okay. Pretty simple. All right, come in here and we're just going to touch here. Take a couple thousandths, engage it. It's really too simple. Okay, 2 down. We're gonna go and we're gonna skim the rest of this, and then we'll bring you back in when we start setting this up, and we're gonna machine the finish on the counterbore recess, the register on this flange side, and then after that we'll turn and we'll set the flange side into the chuck, and then we're gonna start setting up and we're gonna do the finish to that taper bore. We've got this dialed in, and we've taken a skim cut on here already. We started out at like 5 inches 400, and we're 5 inches 450 here, so we got about 25 per side to come out of here. This is 5.5 inch register. This is the first thing we're going to go for because this is light turning. We want to make sure that that register is true with all the other surfaces that are running true on the outside. And then we can come in, and this is just relief on the inside and a face and a radius down in there where the plate that will bolt this to the coupling or draw it on a draw plate for the taper fit will be resting against that bottom surface. So anyway, we're going to take another 20 here. I'm not bothering with a brush or whatever because I want to keep, it's most important to be visual here. Minimal amount of debris going all over the place here. Okay. And we should probably be within about 5 thousandths right now. And we're almost there. About 488. Okay. Looks like it's right on the money, and I'm sure we want to have like a thou or two clearance on that. Okay, we took a couple more passes on this register, and we got it out to where we're reading it the same as the sample with a good pair or our best pair of dial calipers. And right now we're just taking the depth down on that register, so we're going to face out another 50. That's 40 there, but we're going to take another skim cut after this. Have a nice finish there, but we're taking it so the total depth is 250 on this register. We're almost done with facing off that bore, the counter bore down on the bottom, which is actually 5 inches deep from that inner face there. So we got this and about another 10 thousandths to take across that face, and then we'll skim that bore. Do a little chamfer on that inside, a little chamfer on the register there, and we'll be ready to turn this thing in for in and set up for the taper bore. You just need to break this edge right here. About a 32nd. This one right here we could do about an 8. There we go. Ready to turn it around. I got it in this position here. We have the stylus coming in. We've we haven't adjusted our in and out on our ram, but we're moving in enough travel to where we can read the alignment of the mandrel for the tracer, which is a master taper. We just flipped it around, and we got it set up in there, and we take a mag base, set it up on the tracer compound, square off this tool block on this compound, which is stationary to the bed, put the indicator against it. So the combination of inward travel and lineal travel on the bed by this travel dial, I'm able to set the proper taper for 3/4 inch per foot pretty quick and pretty easy, and adjust that the in and out for each of the centers on that back adjustment there to get exactly what I need. So I roll this back here and bring it up to 0 here, and then I set 0 here and there. I travel 6 inches and half a 3/4, and one side of 3/6 is 1875, and I'm right there, and it repeats. I just keep going until I get it to repeat in that position, plus a half, maybe 1, minus nothing, because you always kind of want it greater on the major diameter of the taper than the minor to start with. But we're going to lap fit this in here, and we just want a good starting point. Okay, so we have the alignment of our mandrel. Now we're going to put in the boring bar, come over, touch off, and start cutting. Okay, we're all set up. We got our bar in here. We kind of adjusted it so we got a good motion in there. And now we're going to touch off. And the way I touch off is I usually just come into the beginning here. Oh, first off, before we do that, I just want to make sure that in and out travel, we are located in a good center position on our ram over there. Okay. All right. Now we'll come back in. All right, and we're gonna take 20 thousandths per side here. Oh. Before we do this, I'm just going to put this in here lightly, and we're drawing a line here with the Sharpie. There's the line we want to go to that position there, because that's where the other coupling sets, so that we have this coupling setting on that shaft in the same location. And the draw on the other side is where the makeup or the pressure capabilities are to put on the taper, to draw it onto the taper. So the end of the shaft that's out there, the marine shaft, is not going to go all the way through the bore. It has to be shy of that bore so that the plate can have a positive pressure of holding it on. Okay. We basically have 1 5/8 inch to travel in here. All right, back in here, and we're going to take the first 20. Here we go. We just finished that first cut in there. We're having just a little tiny bit of vibration issues there. We put a piece of lead on the back there. Alright, we're going to roll that in there till it hits. Feels pretty good. That's not really rocking around, so I think we got a good angle there. Okay. Now, we pop that out. Okay, so 20 thousandths per side on our depth there made a 1/2 inch. Okay. We'll take another 20, and that should bring us up to just about a 1/2 inch under that line right there. Okay, there's another 20. Put it in here again, and go ahead and we mark it. And we see that we're continuing up there. Now this last little bit right here, looks like we're just a little bit less, but we're going to start addressing our chatter here. So we went ahead and increased our feed rate a little bit. And I'm not sure if the lead is actually doing anything for this or not. I think just trying to change our feed rate is going to be our first attempt here. And we're just going to be giving it like 5,000 on the depth here at a coarser feed rate. That sounds a lot better right there. Still giving a well enough finish to be able to lap in and get a nice finish there. I like that. We just went out to check the draw on the minor diameter of the old coupling on the shaft, and this face of the shaft is sitting back in almost 3/8 of an inch. So our dimensions and everything else, as far as our web, our thickness into that position, everything is the same. So I'm going to go ahead and take another cut, and I have been coming down here 1/8. This is a little bit less than 1/8 of an inch. So I'm going to jack in. We've been going 5,000s, and I think I'm going to go ahead and I'm going to put in 4,000s, and we're going to go for a finish cut here. So we'll run through with this cut. We'll just double check it with our line. If we're happy with it, then we're going to come across and we're going to give this some face right here, just so that that one scribe line that we put in there will be removed. And this will be completely dressed up and ready to go for the keyway and the hole pattern for the flange. Okay, right to the same line. All right, I'm going to be happy with that, because I don't mind if this laps on and has just a little bit less draw than what's out there. So it should be really, really close to being exactly the same. All right, let's go ahead and we're going to pull this out of here and switch on over to this compound here. All right, chamfered, face, chamfered here, all finished, ready to go.